Well, this is where it really gets interesting. It turns out that volcanoes also deplete ozone. They emit chlorine and bromine that deplete the ozone layer. Now we have two very different kinds of volcanoes. There's the really explosive ones like Mount Pinatubo that erupted in the Philippines in 1991. And they explode huge megatons of gases high up into the atmosphere. Some of these gases, particularly sulfur dioxide and water, form sulfuric acid aerosol. Aerosol is like a mist. And they form this aerosol, and the aerosol grows big enough to reflect sunlight, which cools Earth. So even though ozone was depleted, the net effect is to cool Earth. On the other hand, we have volcanoes we call effusive volcanoes. These are more like what you see in Iceland or Hawaii. You know those stories that you see on camera, the lava flows coming down the mountain and destroying villages in Hawaii. In this case, they're not exploding gases high up into the atmosphere, but chlorine and bromine is being emitted up into the atmosphere that depletes ozone. And this causes global warming. So over geologic time, we find this interplay between explosive volcanoes causing cooling and effusive volcanoes causing warming. Now, a perfect example is the volcano Bárðarbunga in Iceland that began erupting last August. Within 5 months, it had formed over 80 square miles of lava flows and probably had a major effect on the abnormal temperatures that we've seen in recent time. But there are times in geologic history where the volcanoes produce lava flows enough to cover the whole United States. These are times when the Earth got really hot. These are times when the ocean got really acidic. These are times when most species on Earth became extinct. So throughout all of geologic time, there are all these different examples of where there are sudden changes in climate caused by eruptions of volcanoes and the playoff between explosive eruptions and effusive eruptions.